Modern chief financial officers struggle to maintain a competitive edge when economic volatility and fluctuating demand patterns outpace the speed of traditional planning. Internal forecasts are frequently distorted by human subjectivity. Business unit heads often sandbag revenue projections or inflate expense cushions to ensure targets are hit, leaving leadership without an objective statistical baseline. Standalone data science tools rely on disconnected data fabrics. Information is pushed through fragile ETL pipelines to isolated engines, creating high latency bottlenecks. By the time manual rollups and batch processes are finalized, supply chain conditions have evolved, rendering the data obsolete. Legacy EPM suites offer little relief. Their algorithmic sophistication is typically limited to flat linear trend lines or simple moving averages that cannot account for complex market shifts. Oracle Cloud EPM Predictive Intelligence transforms this reactive rollup into a proactive, machine-assisted model. This transformation is powered by a Zero ETL architecture. Because the ML engines execute directly within the Oracle Essbase database layers, data latency is eliminated. Model training and data writes happen natively within the secure cloud partition. By moving the math to the data, architects eliminate the fragility of external pipelines and allow statistical baselines to be generated in real time. To understand how this architecture is built, we have to look at the ultimate outcome in the planner's workspace. In the standard web form, the manual entry forecast column sits directly alongside a read-only, machine-generated baseline. This layout enables built-in governance. The system automatically calculates the variance percentage between the manual input and the auto-predict statistical baseline. If a planner's manual input deviates from the baseline by more than a defined threshold, for example 10%, the platform flags the cell and halts the submission. The planner is then required to enter a text justification for the variance before they can promote the task, making every deviation from the statistical reality a matter of record. To ensure this isn't a black box, planners can audit the machine's reasoning through contextual explainability. By selecting Explain Prediction, the planner can see the exact mathematical algorithm applied, historical anomalies, error metrics like RMSE, and the specific statistical weight assigned to drivers like price and volume. This configuration shifts the planner's primary role from data entry to data validation and strategic justification. But how does that system_forecast scenario populate across global forms before the planners even log in? This is the role of AutoPredict. It acts as a high-volume, automated background engine that processes massive slices of data as a scheduled job. Administrators integrate these runs into monthly ledger close routines using EPM Automate. This script triggers the prediction engine to seed base forecasts automatically. For global organizations, processing dense data across millions of intersections can create significant processing bottlenecks. To scale, architects use paginated dimensions. This parameter splits the block processing across multiple thread nodes, allowing the system to handle massive cross-sections in parallel. This automation replaces weeks of manual baseline seeding with a 5-minute process that runs entirely overnight. One layer deeper, we find the engine configuration, where the specific data mappings are defined. The engine identifies a clean source slice of historical actuals from an aggregate storage reporting cube. This data is then mapped to the target planning cube. It generates 3 distinct bands: the base prediction, the best case, and the worst case scenarios, providing a range of statistical probability. The system can also extend beyond simple univariate analysis into multivariate forecasting. These advanced predictions correlate financial targets with operational drivers, linking metrics like product sales volume directly to average selling price or marketing spend. This complex correlation is handled by Oracle AutoMLX. AutoMLX scans every data intersection and tests multiple time series models, like ARIMA and Holt-Winters, simultaneously. It dynamically selects the specific model with the lowest historical backtesting error rate for that specific slice of data. This provides data scientist-level algorithmic sophistication without the overhead of maintaining individual models in custom Python or R code. This entire architecture rests on the foundational layer, scrubbed historical bedrock data. The engine requires a minimum of 36 to 60 consecutive historical monthly data periods. Any gaps or anomalies in this history must be scrubbed before the engine can generate a reliable trend. A specific challenge arises when predicting across dynamically calculated parent accounts in the dimension hierarchy. The architect solves this by assigning a specific user-defined attribute, HSP-DYNE-PREDICT, to the target members. This allows the machine learning engine to process these dynamic computations natively. Phase 1 is the non-negotiable prerequisite. Proper data preparation and metadata tagging ensure the engine outputs actionable intelligence rather than amplified noise. Looking at the fully assembled architecture, we can see the journey from historical actuals up to the predictive guardrails on the planner's form. This native model eliminates both the human bias of the sandboxing trap and the high latency of traditional ETL pipelines. Perhaps the most significant advantage is that the system is self-refining. When new actuals flow into the ledger, the system automatically backtests and updates its own internal model selections to maintain the lowest error rate. By codifying these statistical guardrails into the core ledger, the EPM architect builds a structural safeguard against economic volatility. Embedding these machine-assisted statistics directly into the workflow provides the finance team with a persistent, unbiased benchmark for every decision they make.